Hi everybody, and welcome back to Unit 4, Notes 4.10. In this lesson, we are going to be talking about function operations, composition of functions, and quadratic inequalities. All right, let's look at our first example. We have given g of x equals 3x minus 2 and k of x equals 3x squared plus 10x minus 8. What I want you to do now is pause the video and see if you can complete the 3 problems that are listed below. Then, when you get done, hit play and check your answers. So again, hit pause, see if you can do these 3 examples because you've done them before. Then hit play when you're ready to check your answers. Okay, let's look at our first one. So it says find g minus k of x. Well, if you remember back on function operations, that's the same as g of x minus k of x. So what I've done here is notice that I've put them in parentheses. And the reason I've put them in parentheses is because I'm not just subtracting 3x squared, I'm subtracting the quantity 3x squared plus 10x minus 8. So what I'm going to do is I'm going to make that plus a negative, and then I'm going to distribute that negative to everything inside the parentheses so that I end up with minus 3x squared minus 10x plus 8. And then from there, it's just a simple game of combine the like terms. Now, let's look at the next one, g closed circle k of x. Well, remember that closed circle means multiply, and that's the same as g of x times k of x. So what that means is I'm simply going to multiply the 2 functions. Now, when it comes to multiplication, you can do double distribute or you can do the box. So I chose to demonstrate with the box. So I put my trinomial across the top, 3x squared plus 10x minus 8. Then I put my binomial down the side. Then it's just simply 3x times 3x squared is 9x cubed. 3x times 10x is 30x squared. And 3x times negative 8 is negative 24x. Then I go with the negative 2. So negative 2 times 3x squared is negative 6x squared. Negative 2 times 10x is negative 20x. And negative 2 times negative 8 is positive 16. Okay, and then we just combine our like terms. And then we end up with 9x cubed plus 24x squared minus 44x plus 16. Now, last example, find g open circle k of x. Now remember, open circle means up, so they want us to find g of k of x. Now if you recall, that's the same as this notation. So what that means is anywhere I see an x in g of x, I'm going to replace it with 3x squared plus 10x minus 8. So that's how I got 3 times 3x squared plus 10x minus 8. Then minus 2. At that point, I just distribute the 3 to everything inside. I get 9x squared plus 30x minus 24 minus 2. Then we simply combine like terms, and I end up with 9x squared plus 30x minus 26. Okay? All right, so let's move on. Okay, let's move on to our next example. Given h of x is equal to 2x minus 1 and p of x is equal to x squared minus 5x plus 1, I want you to pause your video, try these 4 problems, and then when you're ready to check your work, hit play, and we'll talk about how I did them. Okay, so first example says find h plus p of 4. Now there's 2 different ways you could do it. The first way is you could do h plus p, figure out what that is, and then substitute in the 4. Or you can figure out what h of 4 is, what p of 4 is, and then add those results. Either way, perfectly legit, perfectly legal. So what I did was I figured out what h plus p was first. So h is 2x minus 1, and then plus x squared minus 5x plus 1. So I combine the like terms to get x squared minus 3x. Now that I have the sum of those two functions, I can substitute in the 4 in for x. So 4 squared is 16. 3 times 4 is 12. 16 minus 12 is 4. Let's look at h times p of negative 2. Now, you could do this one way. You could figure out what h times p is and then substitute in the negative 2. However, I chose to figure out what h of negative 2 was, what p of negative 2 was, then I multiplied those results. So, first thing I did is h of negative 2. Well, that's 2 times negative 2 minus 1. So negative 4 minus 1 is negative 5. Then I did p of negative 2. So that became negative 2 squared minus 5 times negative 2 plus 1. Well, negative 2 squared is 4. Negative 5 times negative 2 is 10. So 4 plus 10 is 14 plus 1 is 15. Then I simply multiply the products, or excuse me, not the product. I find the product and I multiply the two functions. So h of negative 2 times p of negative 2 is equivalent to negative 5 times 15, which is negative 75. Okay, next example. It says find 2 times p of x minus 3 times h of x. So I'm simply going to do 2 times p of x and then subtract 3 times h of x. So it looks like this. My next step is I'm going to distribute that 2 to everything inside the parentheses. Now when we get to this minus 3, I'm going to make that plus a negative, so that way I can send the sign with the multiplication and I don't have to worry about making any sign mistakes. So I get 2x squared minus 10x plus 2, and then negative 3 times 2x is negative 6x, so that'd be the minus 6x. And negative 3 times negative 1 is positive 3. Now, from this point on, again, it's just simply combining the like terms, and I end up with 2x squared minus 16x plus 5. So again, that's 2x squared minus 16x plus 5. Last example on this slide, they want me to find p of h of x. So remember, I substitute 2x minus 1 in for h of x. So what that means is wherever I see an x in p of x, I'm going to substitute in 2x minus 1. So that becomes 2x minus 1 quantity squared minus 5 times 2x minus 1 plus 1. So remember, anytime you see a parentheses squared, that really means, hey dude, write me twice. So that becomes 2x minus 1 times 2x minus 1. I FOIL or box that, and I get 4x squared minus 4x plus 1. Then I make this plus a negative, and so I distribute the negative 5, and I end up with negative 10x plus 5, and then we've got that little solo 1 at the end. So now, again, it's just simply a game of combine like terms, and I end up with 4x squared minus 14x plus 7. Okay, let's move on and let's talk about quadratic inequalities. Okay, so what a quadratic inequality looks like is something like this. X squared plus 2x is greater than 3. So this is going to be a graph which involves shading because all inequalities involve shading of some sort. So we need to find out. So we're going to use this on a number line. Okay, we're going to do a number line solution set. And so we need to decide what the boundary numbers are. So to find out what the boundary numbers are, we're going to change that inequality to an equal sign, and then we're going to solve the equation. So I changed greater than to be equal to, so x squared plus 2x equals 3. Now, since that is equal, and it's a quadratic, to solve a quadratic, it has to equal 0. So I move that 3 over, and I get x squared plus 2x minus 3 equals 0. Now I have to see, can I factor this? So, are there two numbers that multiply to make -3 but add to make +2? Yes, sir, there are, because there's +3 and -1. So I'm going to make that x plus 3 times x minus 1. I then set each factor equal to 0, and I get x is -3 and x is +1. So I put those numbers on my number line. Now I have to decide, are my boundary points, are they going to be open or closed circles? Well, since my inequality is strictly greater than, meaning there's no or equal to, they're going to be open. And that would be the case even if they were strictly less than. So if there's not a greater than or equal to or less than or equal to, your circles are going to be open. Now we have to decide, am I going to shade in between the circles or off to the opposite ends? Well, to do this, I have to pick a point in between my two boundary points, plug it back into the original inequality, and see, does it make a true statement? If it makes a true statement, then I shade in between. If it gives me a false statement, then I shade off to the opposite ends. So, a number that is between -3 and 1 is 0. I mean, dude, pick the easiest number, 0. So I'm going to plug 0 in to see, does that make a true inequality? So 0 squared plus 2 times 0 is greater than 3. Well, 0 squared is 0. 2 times 0 is 0. 0 plus 0 is 0. Is 0 greater than 3? No, I don't think so. So since that creates a false statement, I know I cannot shade in between, but I have to shade off to the opposite ends. So that's what my inequality looks like. Now, once I've got the graph of my inequality, I have to come up with the actual inequality itself. So I just write an inequality based on my graph. So it says that x must be less than -3 or x must be greater than 1. And this would be your statement. So remember, since you shade off to the opposite ends, that's an or inequality versus an and. So what I've got boxed is your final answer. So your answer includes the graph as well as the inequalities. Okay, let's look at another. Solve x squared plus 6x plus 5 is less than or equal to 7. Well, remember, the first thing we need to do is we need to change that inequality sign to an equals. That way we can solve it and come up with our boundary points. So we make it equal 7, and then I set it up to solve. Now I know to solve it has to equal 0. So I have to move that 7 to the other side. So I end up with x squared plus 6x minus 2 equals 0. Now this is not factorable because I know there are not two numbers that multiply to make -2 but also add to make +6. So since this is not factorable, I'm going to use the quadratic formula. So my a is 1, my b is 6, and my c is -2. So I substitute in all those values. Now remember, when doing the quadratic formula, I always do plus a negative. So that way I get 36 plus, and then -4 times 1 is -4. -4 times -2 is +8. So 36 plus 8 is 44. Now I need to see, can I simplify 44? Well, I know it's not a perfect square. Okay, but it is divisible by 2, so 2 and 22. And then 22 breaks down into 2 times 11. So I have a pair of 2's. 2 times 2 is 4. Square root of 4 is 2. So that gets me -6 plus or minus 2 square roots of 11 over 2. Now I look at the numbers and I'm like, whoa, holy Toledo, Batman. Those are all divisible by 2. So I divide each of those numbers by 2, and I end up with -3 plus or minus the square root of 11. So I've got my two boundary points because I have -3 plus the square root of 11 and -3 minus the square root of 11. Now for space, I'm going to go on to another slide just because I need more space to write. So follow me and Mr. Cat to the next slide. Woohoo! Okay, so continuing on from the next slide, we have that x is equal to -3 plus or minus the square root of 11. Now, the square root of 11 is approximately somewhere between 3 and 4. So let's call it, for grins and giggles, we're just going to say 3-ish. Now, if you want to find the decimal, you can. That's totally fine. But to find my boundary numbers, I'm just going to use ish because it's going to help me approximate. So -3 plus 3-ish would give me ish. So ish is greater than 0. And then -3 minus 3-ish gives me like -6-ish. So that's going to be on the left side of 0. So that's how I come up with my boundary points as to which one's greater than 0 and which one's less than 0. So what I do is I plot those on my number line. Now again, square root of 11 is 3-ish, so -3 minus 3-ish is -6-ish, and -3 plus 3-ish is ish, so that's greater than 0. Now we have to decide, is it going to be an open or closed circle? Well, I look at my original inequality. That's or equal to. So since it is or equal to, it's going to get a closed circle. Now I have to decide, am I going to shade in between or off to the opposite ends? So I pick a number that's between -3 minus the square root of 11 and -3 plus the square root of 11. So I come up with 0. So I'm going to substitute in 0 to tell me which way I'm going to shade. So 0 squared is 0, plus 6 times 0 is 0, plus 5. So is less than or equal to 7. So 0 plus 5 is 5. So 5, is 5 less than or equal to 7? Yeah, it is. So it made it true. So that means I'm going to shade in the middle of my two boundary points. So I'm going to shade in the middle there. Okay, now I've got the graph, but I have to write the inequality that matches it. So since the shading is in the middle, that means x is going to be in the middle of both of those numbers. So I'm going to say -3 minus the square root of 11 is less than or equal to x is less than or equal to -3 plus the square root of 11. And that is your final answer. Okay, let's move on. Last slide. Last example. This example says if y is equal to 1/4 times x minus 2 squared minus 1, I want us to compare the solution sets of 1/4 times x minus 2 squared minus 1 is greater than or equal to 0 versus 1/4 times x minus 2 squared minus 1 is less than 0. So we're going to graph this using the same tricks we used back in 4.1 because it's in vertex form. So there's my parent function table, and here's my new function table. Now, what I'm going to do to go from old x's to new x's is I add 2, and then to go from old y's to new y's, I multiplied by 1/4 and subtracted 1. So there are my 5 points. Here's my parabola. Now we need to compare, we need to look at the graph and see which parts of the graph are greater than or equal to 0 and which parts are less than 0. So looking at the part that's greater than or equal to 0 would be these two parts, because these are the coordinates that would make your y greater than or equal to 0. So we're really kind of saying, okay, where's y greater than or equal to 0? So on the sides of the parabola, so from the x-intercepts, also known as your boundary points, so from the x-intercept up and to the left and from your x-intercept up and to the right, these are the combinations of coordinates that will make your y values greater than or equal to 0. Okay, so let's talk about the coordinates that make it less than 0. So now, again, those boundary points cannot both be or equal to. Okay, so since this one is strictly less than 0, it's really to the right of the first boundary point and to the left of the second. So it's the bowl of that parabola. So the bowl of that parabola is where the coordinates that make y equals 0 occur, or excuse me, y less than 0. So now we just have to write the inequality. So I've got to write the inequality for the yellow part first. Now, since the yellow part, that is not a conjoined part, kind of like the bowl of the parabola, that's going to be an OR. So my first solution set is going to be 1/4 times x minus 2 squared minus 1 is greater than or equal to 0 when x is less than or equal to 0 or x is greater than or equal to 4. So it's those points and then off to the right and off to the left. Now, since the bowl is conjoined, it's a continuous part of the graph, there's no breaks in it, that's going to be our AND inequality. So we say that 1/4 times x minus 2 squared minus 1 is less than 0 when x is greater than 0 or less than 4. So in other words, when x is between 0 and 4, that's where the y values dip into the negatives. All right, so that's it. That's all we have. So you will go on now and you will complete worksheet 10.4. No, I lied. It's 4.10. Excuse me. My bad. So you're going to go, oh, if it's chapter 2, we don't even have unit 10. But anyways, so my bad. Okay, so what we want you to do now is we want you to go and complete worksheet 4.10. Please take note that at the bottom of the problems, like right on the bottom of the worksheet, right after all the problems, there are about 3 slides we need you to copy into your notes for the next lesson to save time. So make sure you get those copied. Those are at the bottom of the 4.10 worksheet. All right, and so that's it. That's all I have to talk about. I hope you guys stay safe. Please continue to social distance. Please continue to wash those hands. Use hand sanitizer. Stay 6 feet apart and avoid large gatherings, aka super spreader events. So stay healthy, and we will see you back next time. Have a good one.